Quantum computing, the future unleashed. Hey, Disrupt IQ fans, buckle up because today we're diving headfirst into quantum computing. A topic so mind-bending, it's going to recalibrate how you see the world. Trust me, you're going to want to stick around for this one. Ever fantasize about a supercomputer that could, in seconds, hack through the toughest security, simulate your brain, optimize your health, predict climate change, or even generate sustainable energy? That's not science fiction, it's quantum computing, and it's happening now. Section 1. A brief history of computing. Alright guys, before we go quantum, let's rewind the clock a bit. Before computers, we humans needed to count stuff. Livestock, profits, losses. The historical equivalent of a calculator? That was Charles Babbage's analog computer, a gear-filled masterpiece that helped in navigation and banking calculations by cranking some levers and pulleys. But World War II shook things up. Enter Alan Turing, the guy who laid the groundwork for today's digital era. His machine could decode Nazi ciphers. But even Turing's digital computers have limitations. They work on a binary language of zeros and ones powered by transistors. You've heard of transistors, right? These are the tiny switches that are the building blocks of today's computers. Imagine a light switch, but it's either flipping on or off millions of times per second. That's your transistor, folks. It regulates the flow of electricity through its circuits, representing either a 0 or a 1. Basic binary code. These bits are the DNA of your computer's operations, allowing for the complex tasks and calculations that our digital lives depend on. But guess what? The universe isn't black and white, it's not just zeros and ones. Reality is complex, it's made up of particles and electrons, and these aren't simple on-off switches. Now keep that in mind as we step into the quantum realm where things get, let's say, less straightforward. Section 2. The realm of quantum computing. Well, brace yourself for a small physics lesson. At its core, a quantum computer utilizes the principles of quantum mechanics, the science that describes how things work at the atomic and subatomic level. Enter Richard Feynman, a physics genius. This guy basically asked, how tiny can we make a transistor? The answer, atom-sized. And at that scale, things get weird. In a quantum computer, an atom becomes a transistor, not just handling the on and off states, but also everything in between. Imagine a computer so advanced it doesn't just calculate here in our universe, but across an infinite number of them. Yeah, you heard that right. This isn't sci-fi, it's real science. Still having trouble wrapping your head around it? Think of Schrodinger's cat. You know, the thought experiment with the cat in a box. Is it alive or dead? In the quantum world, the cat is both, until you check. In the same way, quantum bits, or qubits, exist in multiple states at once. Remember, we just mentioned that in classical computing it's either 0 or 1, like a light switch. Well, qubits work like a dimmer switch. They can represent 0, 1, or both, thanks to a principle known as superposition. Imagine being able to go through multiple pathways in a maze simultaneously. That's what a quantum computer does. It explores all possible solutions at the same time. That's where their enormous computational power comes from. Mind-blowing, right? And then there's entanglement, another quantum principle. If two qubits are entangled, the state of one immediately influences the state of the other, no matter the distance between them. Imagine having a pair of magical dice where if one shows a 6, the other one does too, instantaneously, even if it's miles away. As Section 3. Real-world applications. So let's get down to brass tacks. Why should you, a tech enthusiast living in 2023, care about quantum computing? I mean, it's fascinating in theory, but what's it going to do for you, right? Let's break it down. Imagine drug discovery on steroids, simulating molecular structures in ways classical computers just can't handle. That's right, we're talking about fast-tracking cures for diseases we can't even pronounce yet. Or consider cybersecurity. Quantum computers have the potential to crack encryption methods we currently think of as bulletproof. And for the Wall Street warriors among you, imagine optimizing financial models so intricately that you could predict market changes with jaw-dropping accuracy. But wait, there's more. Like solving complex logistical problems that can make global supply chains more efficient, and revolutionizing AI by solving complex algorithms in the blink of an eye. Quantum computing isn't just the future, guys, it's rewriting the rulebook for what's possible today. Section 4. Who's leading the charge? Now you might be asking, who's out there making these game-changing quantum machines? Let's get into the who's who of quantum computing. Tech giants like IBM, Google, and Microsoft are pouring billions into this space. IBM even has a cloud-based quantum computing service. Google, for its part, claimed quantum supremacy a while back, boasting a computer that outperformed traditional supercomputers at a specific task. Microsoft's focus is a bit different. They're betting on topological qubits, a still theoretical but potentially game-changing approach. But it's not just a corporate race. Governments are heavily invested too. The US, China, and the European Union have launched multi-billion-dollar initiatives. China especially is making strides with quantum cryptography and networks. Even venture-backed startups like Rigetti Computing and IonQ are making waves. It's a global, multiplayer sprint, guys. And it's anybody's guess who's going to break the tape first. Trust me, the quantum race is heating up, and it's a space we should all be watching. Section 5. Challenges and roadblocks. Now, before we all get too excited and start dreaming of a sci-fi utopia powered by quantum computers, let's pump the brakes. Quantum computing is like the Wild West of technology, and it's got its fair share of showdowns. The biggest gunslinger in town? It's called decoherence. Imagine you've got these particles, qubits, ready to do your high-speed parallel universe computations. But these qubits are finicky. They have to be in perfect sync or coherent to work right. Any external interference, boom! Your quantum calculations are as good as gibberish. It's like trying to tune a vintage radio while riding a roller coaster. To maintain coherence, we're talking about chilling these bad boys to near absolute zero and shielding them like a VIP at a rock concert. And let's not even get started on error rates and the limitations on error correction methods. So yeah, we've got some hills to climb before quantum becomes as everyday as your smartphone, but the view from the top, it's gonna be worth it. Alright, we've journeyed through the rabbit hole of quantum computing today, a subject that's as thrilling as it is disruptive. But hey, that's what we're all about here at Disrupt IQ, isn't it? So what's your take? Do you think quantum computing is going to change the game in your industry, or is it just hype? Drop your thoughts in the comments below, and let's get a conversation started. And if you found value in today's deep dive, do me a favor, hit that like button. Better yet, smash the subscribe button and ring that bell so you don't miss any of our future content designed to stimulate your intellect and disrupt your thinking. Until next time, keep questioning, keep disrupting, and let's redefine the future together.